The founding fathers of home electricity, Thomas Edison, Nikola Tesla, and George Westinghouse, envisioned a future where homes could have lights turned on at the flip of a switch. Today, many take for granted the fact that we can come home to air-conditioned, well-lit homes and may not utilize their electricity, increasing their carbon footprint. With a better understanding of where electricity comes from and how it arrives to our homes, we may become more self-aware of how we utilize our electricity and remember to shut off lights and adjust the thermostat when we leave the home, saving ourselves money, energy, and reducing our carbon footprint. Here's an example of electricity making the journey from our homes. It is generated at a power plant, sent through transmission lines, through a substation to distribution lines, and into our homes. The types of generation are nuclear, hydro, fossil, solar, and wind. Here's an example of a nuclear plant. There's a big concrete structure where the reaction is formed, spinning the turbine, generating the electricity, and transmitting it. The pros are that it does not emit large amounts of greenhouse gases, it's a consistent and reliable source of energy, it allows countries to become independent, and has a low operating cost once set up. The cons are that the environmental impact of the radioactive waste, it requires mining and refining uranium, there's a potential for deadly and costly nuclear disasters such as Chernobyl and Fukushima, a high initial cost to develop a nuclear plant, and limited by the availability of uranium. Here's an example of all the nuclear plants in the United States. A hydro plant has water from a dam come through, spins the turbine, and generates the power. The pros is that it's a renewable source of energy, it's a clean energy source, it's cost competitive, it forms recreational opportunities, and contributes to the development of remote communities. The cons is the environmental damage and the interruption of natural water flow, a high upfront capital cost, may lead to droughts, risks of flood and lower elevations, CO2 and methane emissions. Here is a fossil fuel generation. The fuel burns, bringing air in, pushing it out, spinning the turbine, and generating electricity. Here is the coal plant. The coal burns, boiling the water, spinning the turbine, generating your electricity. The pros is the reliable, its ability to supply power during peak demands. It's affordable. It's not expensive to extract and mine from coal deposits. It is abundant. There are over 300 years of economic coal deposits still accessible. It's a known technology. It's well understood, and the technology is technology is consistently advancing. It is also safe. The welfare and productivity of the coal industry employees has greatly improved over the years. Injuries, time lost, fatalities have decreased in the last several years. The cons is the greenhouse gas emissions, the generation of millions of tons of waste, and the emissions of harmful materials such as mercury, sulfur dioxide, carbon monoxide, selenium, and arsenic. Here's an example of a solar and wind generation. The wind moves the turbines, or the solar panel collects. It brings the energy to a charge controller. It either stores it or inverts it and sends the electricity out to us. It is sustainable, there's minimal greenhouse gas emissions, it's a new and innovative technology, and there's many grants awarded in initial costs. The cons is the initial setup cost. It's very high for solar and wind farms. Its environmental impact, such as migratory birds running into the turbines and the disposal of photovoltaic cells. The lifespan of solar panels is not very long, and the large amount of land required to develop these sites. Next, I'll speak about transmission network. The purpose of transmission lines is to carry electricity across distances using high voltage. The transmission system requires less maintenance than distribution system because of the steel structures that it uses. Here's an example of the steel structure. And here's an example of an H-frame structure. Here you can see the insulators used in transmission system. Next, I will speak about substations. Substations are essential in the delivery of electricity because they change the voltage of the electricity throughout the system. Signal failures and changes in voltage can tell an operator where it is happening to create lower outage time and protect the electric system with a series of circuit breakers, regulators, and lightning arresters. The types of substations are tie stations, switching stations, and distribution systems. Each one serves its own purpose. Tie station change voltage from transmission to transmission. A switching station does not alter voltage, but just allows switching to be done to cut off certain parts of the grid, and distributions go from transmission to distribution level voltage. Here's an example of a substation transformer. Here's an example of a substation circuit breaker. These are used to protect the power grid. Here's an example of a regulator, also something that protects the power grid by regulating the voltage level in the substation. The distribution system is the most recognizable. These are the wood poles and small transformers we see on the sides of roads. They run a lower voltage, usually around 12,000 volts. They require a lot of maintenance because of the fragile and how exposed they are to the elements. Here's an example of the poles that you would see in a distribution system. The transformers you'd see in a distribution system. And the reclosers you would see in a distribution system. That is the last stop that electricity has before it goes into your home. In conclusion, with a better understanding of how electric system works and where electricity comes from, I hope you now feel better equipped to manage your electricity and help reduce your carbon footprint. Thank you.